Hello and welcome to Learning Functional Programming with Rescript, lesson number 1. What is Rescript? Rescript is a strongly typed functional programming language. And why might you want to use Rescript instead of JavaScript, given that it compiles directly down to JavaScript? Why might you want to use Rescript instead of JavaScript, given that JavaScript is more widely used throughout the development world? Well, just because something's popular doesn't necessarily mean it is the best solution to a problem, and the guarantees you get with a functional programming language like Rescript are much stronger than an imperative one. We'll cover further what both those terms mean, imperative and functional, but for now, know that JavaScript is imperative and Rescript is functional. A second advantage of using Rescript over JavaScript is actually that Rescript eventually becomes JavaScript. It's called transpiling, and because Rescript eventually becomes JavaScript, you can use JavaScript within Rescript, meaning that all of the functionality of JavaScript can be directly imported into Rescript, and Rescript is just a higher level wrapper around the JavaScript language. Finally, a note about functional programming versus imperative programming in general. Functional programming can be thought of in terms of mathematics, inputs and outputs, and we'll see that specifically in a further lesson. Whereas imperative programming tends to not be able to directly relate, specifically because of mutation and side effects, which we will cover later. In functional programming and mathematics, 5 is 5 is 5, whereas in imperative programming language, 5 might be an object which can internally change its own state. This is something that is deeply frowned upon in functional programming, and you'll see why this eventually leads to cleaner code in the future. Now let's break down the original statement that I said. Rescript is a strongly typed functional programming language. So what does strongly typed mean? Well, a type can be thought of as a classification of a value. For example, what do we call the collection of characters hello? Well, in Rescript we call this a string. And I said something earlier, what is a specific part of this string? Well, in Rescript we call this a character. So there are multiple other types that are primitive, which are the base types of Rescript. And let's go through all of those now. We have an integer, we have a float, we have a Boolean, and then we have something kind of special called unit, as well as regular expressions. And for now, we're just going to ignore these. But an integer is something like 5, or -5, or 0. A float is a decimal number, specifically distinct from integers, like 5.0, 5.1, or something like -5.5. A Boolean is a true false value, so binary option, is it one or the other, and unit is something which does not do anything. Unit will eventually become more apparent later when we talk about functions, but let's ignore it for now. Let's just think of it as nothing, essentially. So next, let's talk about variables. Something that's important about functional programming languages is that variables never change. Variables are something called immutable. So if we assign x the value of 5, this would be how we would do it in Rescript. We say let x equal 5. X is always 5 when we use it in the future. So let's say let y equal x. What is the value of y now? Well, the value of y is 5 as well. We can nest let expressions by doing something a little bit different. Let's say call this x1. We do a curly brace, and then we say let something else. We can use x in here actually. And let's set it to actually some different value. So x in this curly brace is equal to 6 rather than 5. Let's do something else. Let's redo y as well. And what is the value of this overall curly brace? Well, right now it's actually nothing, so this would be unit right now. But if we say return for this whole curly brace, let's return y, this now becomes int as well. Because the last value within these curly braces becomes the value that we are assigning in the let. So it might be a little bit confusing at first when we say that variables never change, but we're using y and x in here inside of the x1 let block. Well, that's because it's a little bit more nuanced than that. X and y are never changing, but the last value assigned to x and the last value assigned to y are used from that point on. So because these are in the let block, they're actually not affected. But say we declared let x equals 7 down here. Well, since it's the last declaration of x, that means that x is equal to 7 from this point onward. But if we used it up here, right here, where y is equal to x, y does not change from 5. Y is still 5. But if we said let y equal x again down here, y is now equal to 7. Because the last time we used it down here, x was equal to 7. So it's directly replaced the last time it's used. We can also do lets with other types. For example, let hello, this is the variable name, equal the string hello. Let's do let z equal false. So those are some examples where we have hello is a string and z is a boolean. So you might notice that even though I said earlier that this was strongly typed, you might think because of that we actually have to declare the types whenever we declare a variable. Well, Rescript actually does this for us. It infers what the type is, but it tends to be more helpful if we actually state what we believe the type is before assigning it. So for example, let's say let the number 5 equal 5. How do I say that I'm expecting 5 to be an int here? So let's just rewrite this. So we do let number 5, I'm expecting it to be an int right here with a colon int equal 5. Now that might not seem helpful because we said earlier that Rescript tells us the type of everything. But let's say we did let number 5 be we're expecting a string here, and we actually give it the number 5. What happens now? Well, if you try this on your own, it will actually give you an error telling you that I'm expecting a string to be put into here, and 5 is not a string. So this lets you catch bugs sooner. In JavaScript, you would just do and just say, okay, well, I think that's the number 5, and then I might be able to put the string 5 in there, and now I'm going around pretending like this number 5 is actually an integer when it's a string, and I have no idea until my program actually crashes at runtime. So before we actually even run our program, we get these errors, and that's why you might want to be using a strongly typed functional language rather than something like JavaScript. So I think that's it for today. If you would like to have the notes associated with today's lessons, which was the motivation for learning functional programming, types, and variables, please look in the description below for a PDF. Thank you for watching.